a mistake, it's not mathematical, it's representation. What did I do bad?
I didn't write down units.
What? Okay, I didn't hear everybody saying something at the same time.
I just put units at the end and show the units on the.
No, it's okay, because I was just showing and calculating. I wasn't giving one answer. When I give one answer, I have to have units. Another thing you see wrong? Say it again. How about the subscript?
I had a B is capital.
Here I used a little b, right? And here I used a large B. It makes it look like it's two different variables. No good. So let's change this one to be big B. You have to make sure that you're using the same variables.
Do you consider these force vectors? The weights or no?
The weights,
Because then you-
they are, but we're gonna draw it. I never put the little line up on top of the things, because you wind up getting sloppy and not putting that in. Okay, anything else given? Determine the forces exerted, magnitude, weight. Surfaces are all smooth, so we know there's no friction, right? Okay, Chelsea, I'm gonna put find here. But what I'm gonna do is, I'm gonna start using my scrap right here to find all the forces rather than writing them first. And I'm gonna make the table at the same time. So Chelsea, you wanna give us some forces that are present here?
Wait.
Okay, the two weights, right? Weight A, weight B. And we know the magnitude and we know the directions. Nicholas? So I should draw them, right? Let's draw them. WA, WB. Nicholas?
Tension, that each of them are exerting on each other?
Okay, there wouldn't be tension, right? Because tension is a pull.
Yeah.
So it's compression, but we could also call it something that you've never in physics talked about drawing a compressive force, right?
Normal.
What is it?
Normal.
It's a normal, right? When I'm touching something, our compression on each other is a normal. So Nick, which normal are you talking about? Just describe what you were saying.
Between that they're exerting on each other.
Okay, so there's some kind of normal in here, right?
Yeah.
Can we call it NAB? It's the normal between the two? Do we know the magnitude of that?
I don't know.
No. Okay, this is a harder question. Do we know the direction?
Yes.
Do you know for sure that this is horizontal? No. You don't, unless you do all the geometry for this. You don't know if the normal's like this, or like that. So we really don't know that. There's some angle in here that we don't know. So we do not know its direction. We could draw it on AutoCAD, and then we can definitely tell based on the dimensions of the cylinders. We can draw it on AutoCAD and see exactly what that angle is. Or-
Isn't NAB the component of those two circles? So shouldn't we have NA and NB
Well, where is NA and NB?
that would be perpendicular to the
Right,
surface?
so there's also a normal that's coming from the surfaces. So there's a normal coming from here, and could we call that NA? And call this NB? So NA and NB. And do we know the angles?
Yeah.
Okay, so tell me what they are. Remember the trick? Two lines, the angle between this and this is 30 degrees, right? So the angle between the force and which axis is 30?
Negative.
So this force is perpendicular to the inclined plane. What line is perpendicular to the horizontal?
One.
Vertical. So this right here is 30. Let's do the other side. The angle here is 15. This force line is perpendicular to this. So supposed to be perpendicular to this. So what's perpendicular horizontal? Or vertical, so here's 15 degrees. So, do we know the magnitude of NA and NB? Eric, since you were doing it,
Yeah,
we know the magnitude, did they give it to us?
well, we need
We have to calculate it using equilibrium
oh,
equations,
okay,
right?
fine,
So we don't know yet. So we don't know, and we don't know. But do we know the directions?
yeah.
Yeah. So, a magnitude is only if the numerical value is given to you or a cable holds a weight. That's the only time you know the load, the force. Otherwise, you have to calculate it using equilibrium equations. Very good.
Do we have the y-axis and x-axis labeled?
We have not done that yet.
Okay.
We only do that once we get our free body diagrams, because we're gonna pick an axis that makes us do the least amount of work,
Okay.
okay? We're not being lazy in that
What
situation.
does scrap mean? You probably already said it, but I missed that.
I'm just drawing stuff on here, but it's not representing my free body diagrams. So when we looked at this problem, I was drawing things on here, but it was all just my scrap work. This was my free body diagrams. Okay, anything else? So far we have the two weights, we have the normal between them, and then we have the normal coming from the surfaces. Jason, do you see any others? No, there's no friction because it says, assume all surfaces are smooth. So that's it. So Jason, how many unknowns do we have? 4 unknowns. How many equations do we need? 4 equations, you just jumped ahead. And how many bodies? Because it's 2Ds. So we need 2 bodies. Okay, let's draw the free body diagrams. What bodies, Jason, do you want to analyze? You said you wanted 2 bodies. Which bodies do you want to analyze? A and B. And do a number of forces converge on A? Are there a bunch of concurrent forces at A? Are there a number of concurrent forces at B? So those are the 2 good places to draw them. Jack, can we reduce A to a dot? Or or describe when you can reduce it to a dot? Because there's no friction, but why would friction cause you to not be able to do it? Not concurrent. So because the only forces we see on A are all concurrent, going towards the center, we could use a dot. Does everybody have that? Okay, Daniel and then Chelsea.
So if the center of masses weren't level on these 2 circles here, then there wouldn't be, would that still be concurrent?
No, you're right, they wouldn't if they're not homogeneous, but they're homogeneous. And typically in engineering, there's something called a factor of safety, and you're always gonna apply a factor of safety to things. So typically we're dealing with, even though there's no perfect homogeneous material, we always assume things are homogeneous. So those of you who took materials, when you did a bunch of tension testing on aluminum, you might have gotten some where they were a little bit stronger than they were supposed to be, because all materials are really heterogeneous. But the assumption we make is homogeneous to simplify the problem solving, and then we add in a factor of safety.
I think I was asking the center of masses, if they, the center of mass of the smaller circle and the center of mass of the bigger circle, if they were not, do they have to be at the same level?
Oh, okay, no, I see what you're saying.
Yeah.
If the center of mass of the smaller one and the center of mass of the larger one, that's what's going to determine the angle of NAB,
Okay.
whether it's up or not.
Yes.
Chelsea?
I was just gonna say, because If we don't know NAB, I thought it might have like some angle, we don't really know.
We're gonna have to put an angle in,
So
and we're
then,
gonna have to take a guess.
does that mean it's concurrent still?
Yeah, because it's still, even though it's gonna be up at an angle, even though it's gonna be up at an angle or down at an angle, it's still going through that point.
Okay. It still has to be like, yeah.
If we could geometrically put the center here, put a dot here, put a dot here, we would know the exact angle that NAB is at. But we would have to do it geometrically. Okay, so let's draw the free body diagrams. And you're gonna notice from Enrique's question, we're gonna wait and put the axes on at the end. We're gonna draw the forces first. So we have force A, not force A, sorry, body A and body B. Is everybody comfortable so far? I drew body A, I drew body B, I drew the weights going down for both of them, I drew the normals from the surface. And what do I have left to draw? The normal between the two, right? So how many of you, we're not gonna be able to determine this now because we're not gonna do the number crunching, but how many of you think NAB is horizontal? Okay, so then that would mean that the angle would be 0, right?
Yes.
How many of you think it's going down like this? How many of you think it's going up like this? Okay, you gotta call a shot. Horizontal. Down to the left. Up to the left. Okay, most people go this way, so that's what we're gonna draw. NAB, and we're gonna call it theta. So how would I draw NAB going on B? Everybody show me with your arm. So I have NAB, the load, the normal from cylinder B going towards A, going up to the left. How, using your arm, show me which way NAB is going to be drawn on B. Good, down to the right. So Jose, if NAB on this one is drawn up to the left, why is this one drawn down to the right? So give me your hand. So I'm pushing down that way and you're pushing up this way. We're equal and opposite, right? So if one is going up to the left, one's got to go down to the right.
Yes.
Because if I put these two things together, if I put cylinder A and cylinder B together, what happens to this in here? What happens to that load NAB in here? It cancels out because this one is going up to the left, it's going down to the right. And does it make sense that it should cancel? Should it cancel when I draw these two guys together?
Yes.
Yes, why? Because it's in equilibrium and these, now they have to be equal and opposite by, what is it, the third law? And this becomes an internal force, right? And I'm not going to draw it now. It's got to be equal and opposite. The load that A is putting on B is equal and opposite the load B is putting on A.
So it would be wrong to draw horizontal.
It would be wrong too because we don't know which way they're angled. So we would have to draw it either like this or opposite. We have to put in an angle because we have not determined whether it's horizontal or not. Are any of these forces known here? We know WA, right? What is it? Newtons? And what is this one? 800 and?
82.9.
Okay, so what's unknown? This is unknown, this is unknown, this is unknown, and this is unknown. So there are 4. How many unknowns are there now? We had 4 unknowns, so did we forget something?
The direction of the.
Ah, yes, the direction, good. This is an unknown. There's our 4 unknowns. So I probably don't want to circle this twice. So let's go back to the problem, because remember, we never put in what we have to find. And I wanted to make sure that I was using the right variables. So it says, determine the forces exerted on the cylinders by the inclined surface. So what's that?
NA and
NA and
NB.
B. And the magnitude and the direction of the force exerted by cylinder A on B when the cylinders are equilibrium. So isn't it telling you that you have to find that direction? Right? So you need to find NAB and what? And delta. Didn't I use a delta? Is it delta or theta? Theta. Yeah, Rachel.
So, on the quiz or test, do we have to put the given in mind when are you put that in the table?
Yeah, you have to write it because in engineering, anytime you solve an engineering problem, you're always writing given and find. This is just a graphical way for us to really make sure that we're defining everything. So yeah, you have to put both. Okay. Jose, question?
So then we would then leave the find more towards the end?
No, just in this case I did because I wanted you guys to choose what kind of variables you want to use. And I know that when you see the picture, it'll be probably clearer to you, oh, okay, this is coming off the inclined surface and we're going to call it NA. So then I wanted to go back and do it.
Okay.
I thought this might be easier for us to do first than reading through the words and figuring out what we want to call everything. Okay. So we did 4 setup problems, and now I want to go through and we're going to do a full problem now. Okay? So remember last week I gave you this sheet that has the setup on one side and on the other side it has some problems. And we're going to do this problem first. Is there any need to stand up? And stand up and stretch? Yeah. No, it's not. That's why I put it out here.